Viewers and subscribers, welcome to another edition of Green's Electrical School. Yes, I'm right here about to work out a circuit, a series parallel circuit. Right, we are not going to do any calculations. I'm just going to help you guys to understand how this stuff works. All right. When it comes to series and parallel circuit, I know it brings a lot of confusion. I can tell you that. It brings a lot of confusion, and persons often look at these circuits as, oh no, they are too difficult, and your head begins to swell. Well, I'm here today to tell you, don't let your head swell. There are ways and techniques to work this thing out, and once you learn it this way, I can tell you can tackle any circuit, any series and parallel circuit in the world. Alright, so I want you guys to look at the circuit very well. As you can see, we have one resistor here, and this is the symbol for resistor, for those of you who don't know. In other words, it represents a load as well. Alright, so 1, 2, 3, 4, 5. 5 resistors connected in a series and parallel circuit. Now, the key thing to this is to understand which resistor is connected in parallel and which resistor is connected in series. Now, we know that a series circuit is a path where there is only one path for the electricity to flow, and once one load is damaged, then the other one cannot work. We get that straight? So that is a series circuit. Now, a parallel circuit means that there are multiple paths for the electricity to flow, and if that one part get damaged, then it won't affect the other path. So we're going to look at this circuit now. We're going to see what is in parallel and what is not in parallel. So here we go. Now, I want you guys to imagine this circuit very simple as a water channel. Imagine that these lines are pipes. You know, these lines here are water pipes. You know, those water pipes, regular water pipes you have. And this here, this is the battery. But I want you to imagine it as a water tap. You know, the thing that to turn on the water, that valve that you spin. Imagine this is a water tap. So, according to this circuit, if you look at this symbol, it says I. It determines the flow of where the current is flowing from. So it's flowing from this side to this side. It goes around the circuit and come back here. Alright? So go back to our water channel scenario. When you turn on the pipe, the water gonna flow through this pipe. I hope you guys can follow me. It's flowing, it's flowing. But when it gets here at point A, some of the water gonna flow here and some gonna flow down here. Right? So already we know there's a split. So one gonna flow here and comes down through this resistor here. The water gonna flow down here, and then it's find its way back to the other end of the circuit. You understand that? So right away we know that this resistor right here is connected in parallel, meaning it has its own independent flow of electricity, or if we're still using the water analogy, its own flow of water to get back to the source. See? But over here, when it's split, it goes through this resistor, then it goes to this resistor, then it comes to this split group here. Once it reaches here, some of the water going to split, come through here, and some going to split and come through here, and flow back right to the source altogether, right? So we know that this resistor is in parallel to these other resistors over here. They're in parallel. But, here's a but. Once you reach here at this resistor, water is flowing from point A to R1 here. Then R1 is in, R2, sorry, this is R2. It's labeled R2, I hope you can see it. Is in series with R3. So, what that means is that R3 is dependent on R2 to get powered. Okay, so we would have understand that R3 would have been dependent on R2 to receive power. So hence, both of them would have been in series. All right. So that's what a series circuit principle is. It would have been dependent on when a resistor is dependent on the other to receive power. They are connected in series. But whenever you come down here, these two resistors, the current would have split. Some would have gone here, some would have gone over here. So therefore, these two resistors are in parallel with each other. Alright? So, but they are in series with these two resistors because they are dependent on these two resistors for them to receive power. right? You understand? But yet still they are not dependent on each other to receive power, right? So these two would have been connected in parallel, but yet still they are in series with this resistor here, and they would have been connected in parallel with this. So to calculate this circuit, you would have to isolate this resistor from these resistors over here. Calculate these resistors, whether you're finding the total resistance or the total current. You'd have calculated these resistors independently, and then you would have calculated this by itself to arrive at a steady answer to avoid confusion. All right. So if you're finding, like, for instance, the total resistance, you just do this side first, and then you would have add this side to it as a parallel group. All right. You'd have just add this resistor to it as a parallel group. You'd have just calculate the total resistance here, form it into one resistor, and then you calculate this and these resistors over here as a parallel group. All right. Versus also the total current of the circuit. After you'd have finished, calculated the current here, then you'd have to work out now the current on this side here. You'd have to find the total resistance on this side. You'd have to find the total current here, and add this to it, and then you'd have got the total current. All right, guys. So, but we work through some of the principles of this circuit in the next video. But I'm just showing you how to understand it, break it down, and have a proper understanding before you attempt to work it out. Because if you don't analyze the circuit properly, then you're going to run yourself into problems. Alright, guys, hope this video helps. See you next time.